Welcome back to EESC 315. This is Lecture 17, Alternatives Assessment. Today's photo is from the town of Peace River. This is downstream of our case study. This is on the Alberta side of the border. Just a nice float down the river through the future site of another possible dam called Dunvegan towards the Peace Athabasca Delta across northern Alberta. So today I will be talking about different types of alternatives assessments. You may recall earlier when I talked about scoping, there are two different types of alternatives. So there are alternatives to the project, which is an entirely different way of meeting the project's objectives. So for example, if the project's objective is to generate power, you could either do that with a wind farm or a coal-fired power plant or several other types of power generating stations. And these are all alternatives to a given project. Alternative means, on the other hand, is a different way of doing something that is within the same general type of project. So this can be a different siting or location, different sizing, different configuration. So for example, if you're doing a wind farm, it would mean maybe using different models of windmills or other sort of aspects of the project that don't radically change the overall project, but make minor changes within that project. I'll talk about some of the legal basis for having to do these shortly. And I just want to mention that most of the talk today will be on a practical way of doing an alternatives assessment. And a lot of alternatives assessments are done within EIAs, but also beyond the EIA itself. Even if a project is approved, alternatives assessments will go on several times throughout the project because information will change and decisions need to be made, and it's often not clear what is the right or optimal solution to a problem. So the method that I'm going to be going through in this talk today is very common to environmental science and engineering. It's used for all sorts of different problems, such as how to dispose of waste, which water treatment plant to build, where to locate something, all sorts of different decisions that need to be made, often when there are competing criteria. In other words, a decision might have a benefit in one area, but a cost in another area compared to another option, and it's not really clear which is the better option overall. So I'll go through how to do that. I'll first spend a few minutes on the legal basis and some of the sort of high-level requirements. So I'll start with the provincial requirements. As you can see, the provincial and federal requirements are similar. In BC, under our BC Environmental Assessment Act, Section 25, the following matters must be considered in every assessment. Alternative means of carrying out the project that are technically and economically feasible, including through the use of best available technologies and the potential effects, risks, and uncertainties of those alternatives. So the Canadian Impact Assessment Act has something similar, and I won't read it because it's almost identical, but it basically says you must do an alternative means, but it also has an alternatives to. So this is in the federal requirement, but not the provincial. So any alternatives to the designated project that are technically and economically feasible and are directly related to the designated project. So this is something that must be considered. Now, in textbooks such as Noble, I'm going to read from Noble in a moment, but it highlights one of the challenges with alternatives to a project. So for example, if you're doing a mine and say you've got a copper mine and you're the proponent and you would like to develop your copper mine, there really are no alternatives to that project to get copper. The only way to get copper is to go out and mine it. Now, you could say that we can do better recycling. I can actually tell you copper is recycled very well. It's one of the few things that is actually very efficiently recycled already because it is so valuable and it is highly recoverable. So aside from improving global recycling prospects, there is no other way to get copper besides mining it. So there are other industries like that as well, where a proponent really doesn't have an alternative to the project that's viable. And the Canadian Impact Assessment Act policy documents recognize this. So I've put a link here on this slide, and I will also post this link on Canvas, but it has an interesting policy document that I'll go through shortly. But first, I just want to read from Noble because Noble makes an interesting point about alternatives to a project. So he says, in practice, alternatives to are rarely considered comprehensively in Project EA. When considered, they often reflect narrow agency or proponent goals or are biased towards the proposed projects. Alternatives to a proposed project are typically limited to the no action alternative, which is interpreted as either no change from the current or ongoing activity, or no activity, which refers to not proceeding with the proposed development. So, of course, the reason for this is that even if there are other viable alternatives to a project, it's really not in a proponent's best interest to point out that there's actually some other entirely different project that would be better overall for either society or for the environment or for other factors that really aren't in their best interest. So there's quite a few problems with doing an alternatives to a project, but the alternative means of carrying out a project are where some big gains can be made, because sometimes the proponent doesn't even realize there are better ways of doing things, or they've got their sights set on one certain method, and doing an alternatives assessment can actually help them change their minds and convince their management or whoever needs to make a decision that there's actually a better way of doing things, and it's not just better for the environment, it's not just better for society, but it's actually better for the proponent themselves. It's better for economics. It might be better on a number of different grounds that are not immediately obvious. And so I'll walk through that process shortly. But first, I'm going to go to the Canada Impact Assessment Act policy page and just highlight a couple of things there. Okay, I'll just spend a minute or two looking at the Impact Assessment Agency of Canada's website. It's got some interesting parts here about alternatives assessment. I've posted the page on Canvas, so please read the whole page, but I will just focus on a couple of places. So in the planning section, what this talks about is how alternatives are considered throughout the environmental assessment project. So I mentioned it when I talked about scoping, and really that is the historical context for alternatives assessment in EA. It was a scoping exercise. But what's new in the Impact Assessment Act of 2019 is that alternatives assessment is now used throughout the project. So initially, it's really a communications tool for the proponent to really describe. It's related to the need of the project, the purpose of the project, and how that relates to any alternatives that there might be. But it really becomes a decision tool later on. So throughout the impact assessment and the impact statements, the alternatives are considered along with best available technology, and they're used as part of the decision-making process, including the decision statement. So the decision maker, who is often the minister, must consider alternatives as well. So that means that the minister or the governor and council will need to consider the alternatives that were put forth by the proponent and that have been through the public participation process, so that interveners and others who will help make that decision or help provide information for the minister to help make that decision have really had the opportunity to consider alternatives to the project. So this site goes through considerations, and the interesting part that I'll also focus on is some guiding principles. So consider the alternatives assessment as a process for optimizing the project. So this isn't just a rubber stamp sort of exercise, as some people have criticized EIA for in the past, but it's really an opportunity to thoroughly think through a decision and to consider all the aspects of each alternative. So I'll go through this in practical detail shortly, but it allows the proponent to consider the social, environmental, economic, and sometimes technological impacts of any given decision. One of the guiding principles is that if new information is obtained, consideration could be given to adjusting the alternatives. In other words, making this decision at the scoping stage of an environmental impact assessment doesn't lock you in or lock the proponent in There should always be an opportunity to go back and revisit the options analysis or the alternatives assessment if new information shows that there's a better way of doing something. So it should facilitate an open and participatory process. I will talk a bit more about this in practical terms, but from the government's perspective, what they say is the engagement of external parties facilitates transparency and may foster greater support for projects and decisions. So that is absolutely the case. If you can include stakeholders in the decision-making process, obviously they're going to be much more likely to buy into the decision in the end, as opposed to what is often done, which is the proponent simply showing the stakeholders how a decision was made and hoping that they will accept that decision. So scope the assessment of alternatives. Proponents should not be expected to consider every plausible alternative, and I won't read the rest, but what this means is that there needs to be some sort of a reasonable level of effort applied to each alternative assessment. You can't do a full environmental impact assessment on every different option, otherwise you will take 10 years to make a decision, but you need to scope this properly so that you're considering the right level of information for each decision. Next is apply the sustainability principles, and there's a whole different guidance document on this, but essentially what it means is you need to consider both short-term and long-term costs and benefits. You need to consider economics, environment, social aspects, and then provide clear and complete documentation. So you need to explain all of the different criteria you use in your decision and how you come to those rankings and weightings if you apply any. So again, this is just some sort of high-level instruction from the government. I will go back to my slides and start getting into some more practical considerations and instruction on how to do this.
So alternatives assessment. So why do one? We're going to cover that really quickly. We're going to focus most of our time today on how to do one. And again, sort of like modeling, this is actually a really good skill to have if you're working in industry. For some reason, there aren't many people who know how to do this, even though it's super simple. I think the main attribute of somebody who does this is basically just somebody who likes to stand up and talk. So I get asked to do this quite a bit for different companies, and I really enjoy it. Like I said, the reason I enjoy it is because everybody comes into a room with some idea about what the best decision is. Everybody's got a different idea, and at the end, most people agree that there is one winning alternative. So why do one? At its essence, what we're trying to do is we're trying to balance competing factors. So often, the main factor is economy versus the environment. The cheaper the project, the worse it's going to be for the environment. That's sort of the high level. But within that, there's lots and lots of details that we can factor in. There's also social factors, and often these are competing as well. Stakeholders always want the company to go with the most expensive option in terms of mitigation. The company doesn't want to. They don't want to spend money unless they really need to. But once we get into the details, you'll see how it gets a lot more complicated than simply economy versus environment. So what we're trying to do is we're trying to improve the decision-making process. We're not using a tool to make the decision for us. We're using a tool to help us understand objectively what the decision is and the reasons for it. Second reason we use this is to actually document our decision. So if BC Hydro had decided a certain mitigation was not going to be part of the project, they would want to use a tool like this to show in a lot of detail why they chose not to do that. Often you also have technical people who are trying to support a decision made by managers or decision makers, and I'm very happy to say I'm not a decision maker when I do this work. I don't have to make any of these decisions about who buys what, and that's thankfully not my job. But I get to help sort of provide all the information that goes into a good decision. I also don't decide on whether a project should go ahead. So this is all sort of, as a technical person, giving the information in a lot of detail and comparing options in a very rigorous way to show what is the most objective decision. So it's a requirement of most EIAs, not always, but there are certain things that require an alternatives assessment. The main one is tailings dams. Both the provincial and federal government require lots of this work to go into any decision around tailings dams because they're probably the most high risk to the environment thing on earth. So they want to know, why did you choose the site? Why did you choose the dam construction? Why did you choose the water elevation? Why did you choose all of these things? Show us in a lot of detail all of the factors that went into this decision. And then of course these go out to the public, usually, not always, but sometimes, you know, the public will look at this and come to an understanding about why a certain company made a decision. But at the end of the day, the reason we would use a tool like this is because humans are terrible decision makers. We don't make decisions very well. We have biases, meaning we come into a room thinking we know what the best option is. We have blind spots, meaning that we come into the room thinking, you know, we need to pick the project that gives us the best water quality. Somebody comes in and says, we need to pick the one that gives us the lowest noise. And so we're blind to each other's areas of expertise. We have preconceptions and preferences. So all of these things come in and make us really poor decision makers. So we need something that's more objective. And so I'm going to talk about the tool very shortly, but there's an important part of this, which is stakeholders. I have been part of these in the past where we involve stakeholders directly. In other words, everybody who's got a stake in this, regulators, the public, basically anybody, the same parties that would be reviewing an EIA are actually part of the process to help the company decide what is the best type of mitigation or the best method of dealing with something. And if you can actually get everybody to agree, including the stakeholders, then you've got a very clear and easy path forward to approval. Now the caution is that stakeholders are often not able to reach a consensus with a proponent because parts of the decision tool they simply just don't care about, namely cost. And I have been part of these before where a single participant can completely railroad the entire process because you're trying to have a consensus-based tool here if you're bringing stakeholders in. And if you've got somebody who's violently opposed to something, they can really railroad it. So it's a bit of a caution. This is a very typical options analysis tool or alternatives assessment. Decision support systems, multiple accounts analysis, options analysis, alternatives assessment, KT analysis, these are all basically the same thing. It's simply some numerical tool that shows how you made a decision, what are the factors that went into it. They're slightly different, but close enough for our purposes. So here's an example of one. This is one that I actually did with stakeholders. This was for the Mount Poly mine, trying to understand where they would discharge their water. And so in this case, we had Department of Fisheries and Oceans, Ministry of Flinro, Ministry of Environment, Ministry of Mines, 2 local First Nations, 2 different community groups, the mine, the technical people. It was a giant process. And we actually got through it in one day, which was amazing. So essentially, this is your tool. What you do is you look at your primary criteria and your secondary criteria. These are the things that you're going to use to make the decision. So the primary criteria, also referred to as non-compensatory. In other words, you can't compensate for this. It absolutely must be in here. It's also known as a fatal flaw. So in this case, we listed 2 criteria that if the option didn't meet it, it was off the table immediately. We don't assess it any further. So environmental, does not cause adverse impacts to aquatic, terrestrial, human health. Legal, complies with all applicable provincial and federal policy and law. So those are pretty standard things. Often there's a technical thing put in there too. There must be materials available to do this, or it must be technically feasible, or whatever it is. It's kind of a screening criteria that you can look at an option right away and go, we're not going to look at that one any further. And in fact, what you're seeing here is the result of the options after we had done that. So often you start with like a dozen options. You screen a bunch out because they're just terrible options. But by having them in the table in the first place, you can actually show people, yes, we did consider it, here's why we're not going to use it. And then going down the table, we have secondary criteria, which are often broken into always environmental, social, and economic, and often also technological. And so in the environmental category, assimilative capacity, so basically which option is able to accept the discharge without harm. Aquatic effects, there's always going to be some sort of aquatic effect, so which one has the least aquatic effects. Terrestrial effects, this was related to building a pipeline. Long-term sustainability, so some options are good for a year, some are good forever. And then under technological, risk and consequence of failure, so with lots of different options, each one has its own risks of, a pipeline burst or something going wrong, and in this case, which option is going to be the worst considering the types of failures that it can have. Complexity, lower complexity is almost always preferred because some poor engineer is going to have to actually design this and stamp it at some point, and if it's nice and simple, they're happy. If it's complex, it's not just that it's a lot of work for them, it also leads to other problems. So flexible design, that's a really good one. You want your option to be able to adapt if something happens. So a non-adaptable option is usually pretty unpreferable. And then a risk of non-compliance. So even though we've said the option must comply with all environmental and legal factors, there's always a risk that something is going to put you out of compliance in the environment. There's always something that can go wrong, and some options have a higher risk than others. And then social, for the social factors, we looked at what the stakeholders were saying, and we lumped it into two categories. Number one was restoration of fish habitat. That was by far the number one thing they wanted to see happen. So whichever option would allow that to happen soonest was the highest ranked. And then we also put the general acceptance of options. So we'd heard that they had preferences, and those then became rankings for this line. And then economics are almost always broken into capital and operating costs. So capital cost, how much does it cost to build it? Operating costs, how much is it going to cost you per year for the rest of your life, or for the rest of the project's life? And then the interesting part here is the weightings. So the weightings are a reflection of how important this is to the decision. And this can be sometimes straightforward, sometimes it can be a major undertaking to try and understand how important each factor is. And so what most companies do is they start by dividing each of these equally. So if they do environmental, social, and economic, each one of these is worth 33%. If you have 4, now they're each worth 25%. That makes your life a lot easier because now you can look at this and say, within this 25%, how important is each factor? And so in this case, minimizing effects on the receiving environment, so the aquatic was twice as important as any other factor. Technologically, we thought they're all about the same, socially about the same, and cost, each one's about the same. So these are the weights, and then once you've got that set, now what you do is you go through and you rank them. And the ranking, you do one line at a time. And the reason you do one line at a time is because you want to compare all of your options only considering this one criterion. So basically you completely ignore everything else in this table. Otherwise you can't make it an objective decision based on assimilative capacity. And so I'll use an easy one, capital cost. It's easy to cost out something. I mean, it's not easy, but it can be done relatively easy and objectively. And so if you completely ignore everything else in this table, you can now rank these. So there should be a 1, 2, 3, a 4, and a 5. So the ranking is purely the order of preference. And then the score is the weighting times the ranking. And that gives sort of usually higher score is better, and a lower score is poor. So rank of 1 will give you a poor score. And so in this case, we did the status quo. You should almost always do the status quo unless that's not even an option. And then you add them up at the end, you get a final score, and that tells you, according to your objective tool, which is the best option. Doesn't mean you have to go with that option, but it definitely supports your decision. So I'll just recap that quickly. The things that you need to put in your tool is the decision that you're seeking, a list of options, some commentary on each option so that people understand exactly what that option entails, and then your list of fatal flaws, and then your list of criteria, which usually includes those 4 things. And then normally you would put in some preliminary weightings, subject to change, because once you start doing one, it'll change for sure. So having the preliminary weightings in there is helpful though, because if you have nothing in there, there's too many degrees of freedoms. It's good to start with something. Okay, so let's do one. So I've chosen a big decision that a proponent would have to make, and I understand BC Hydro actually did this in some format. I intentionally didn't go look at theirs. You probably should, because it might have some impact on your technical study. But let's say BC Hydro comes to us and says, we want you to do an alternatives assessment on alternative means to the project, alternatives to the project, not alternative means, but complete alternatives to the project. We're not sure if the dam is the right project to build in northern BC. We know there's lots of other things we can do: nuclear, gas-fired, coal-fired, windmills, solar panels, geothermal, biomass-fired. All of these are available technologies. We can't decide which one we really want to build. Or they might come to you and say, we want to build a dam. Can you make sure that we haven't missed any other good option? So we have some criteria. The absolute requirements, so must be legally allowed in BC. Otherwise there's not much point looking at it. And it must generate 1,500 megawatts of electric base load. Not just that much power, but we need base load because people run things at night and they run things when it's not windy. So we need a base load, we need it to be legal. And here's some criteria. So we want to minimize disturbance to the aquatic and terrestrial systems. We want to minimize air pollution, minimize carbon emissions, because it's a power plant, it's a big issue. Economics, here's our CapEx and our OpEx. And we want this to be socially acceptable, so we don't want to displace communities. And just as a side note, displacement of communities is a huge issue. With Site C, they did displace a few farms. It was relatively minor compared to, say, the Three Gorges Dam, where they displaced over 1 million people. So imagine that. You're flooding out tons and tons of different cities and telling over 1 million people, go find a new home. That probably wouldn't fly in northern BC. And then we want to use renewable resources if we can. So these are the criteria. And again, some of these might be competing. Some of the things that we would do to minimize our social footprint might cost us more money. And some of the things environmentally might not be as good socially, you never know. But let's have a look. And last slide before we start. If you're doing any kind of options analysis, the most important rule is make sure all the rules are clear at the start. So all of these rules I've put in here are totally up for debate. But if you don't agree on these before you start, you're dead in the water, because you're going to get halfway through it and somebody's going to say, you know, let's use half numbers, or let's make sure everything's linear, or, you know, all of these things can actually really screw you up because it makes you go back to the start. It's kind of like if you're playing Monopoly and somebody wants to introduce their own little rules, but they don't tell you until halfway through the game. And all of a sudden, somebody's throwing the board in the air. That's pretty much what happens here. So, number one rule is agree to all the rules before you start. And a really important one is that the outcome is non-binding. People need to understand that. So often, if a stakeholder is involved in an options analysis and the proponent ends up going with some other option, that can lead to a disaster for public relations. But at the end of the day, it's a decision support tool, not a decision-making tool.
And these rules are always open to debate, but in this example, we will only use integers in our tool, and you'll see what that means shortly. In other words, we're not going to use decimals or anything like that for ranking our options. Rule number 4 is that ties are not allowed. So when we rank our options, one must be better than the other. We can't say that two are equally as good or bad as each other, and that just helps us differentiate.
And then the last rule here is that the highest score means the best option. So even though we might score things based on cost, for example, if something costs $1,000,000, that would be a 1 compared to something that costs $100,000, which would be a 5. In other words, the numbers where we rank things are related to how good they are, not the magnitude of the actual values. And that will make sense shortly as we get into an example.
Okay, I've got a template filled out here for the example that we're going to do. So as I mentioned on the previous slides, we've got a decision that we need to make about alternatives to a hydroelectric dam. So we've got our alternatives along the top here, as you can see. I'll be using this Excel sheet, and I'll just mention that I will be zooming in shortly, and you'll see why very, very soon. So apologies if it's quite small right now. This is our COVID world where we must do everything online, and this is much more fun in person, but please bear with me, and I'll try and make this as interesting as I can. So we've got a decision that we need to make. We need to do an alternatives assessment on all of these different options. And I'm using the same template that I used in the water treatment and water discharge option earlier. But now we're comparing different alternatives to a hydroelectric reservoir to each other. So we've got some primary criteria. And now that you've seen the options, I'll zoom in a little bit. And you can see that our primary criteria consist of the project being legally allowed in BC and the project generating 1500 megawatt baseload. So let's start with legally allowed in BC. So do nothing, that is legally allowed. Hydroelectric dam, that is legally allowed. Nuclear. Nuclear is not legally allowed in BC. So what we'll do is we'll put an X next to that. And once we have an X next to something under our primary criteria, we can actually just hide those columns. We don't need to evaluate it any further. If it doesn't meet the primary criteria, it is not going to be worth assessing. And the reason I'm going to hide it and not delete it is because we want this decision to be transparent. We want to be able to remind ourselves later if we come back to understand why we didn't evaluate nuclear in detail, or if somebody asks us why we didn't evaluate nuclear, we have an easy answer. It just shows right in the primary criteria, it's not allowed. So I'll select these and I will hide these rows. And I will scroll across and we can see that gas-fired, coal-fired, windmills, solar, geothermal, and biomass are all allowed. Maybe they're not preferable. We'll find out. But they are, none of them are legally banned in BC. So next, will our option generate 1500 megawatt baseload? So do nothing. No, that will not. That does not meet our primary criteria. So we can hide do nothing. We don't need to evaluate this option because it doesn't meet our objective. Hydroelectric, yes, can do. Gas-fired, can do. Coal-fired, yes. Windmills, no. We might be able to generate 1500 megawatts, but not as a base load. So the base load is a constant, reliable supply of electricity, and windmills might be part of our electric makeup, but it's not going to supply our base load, so we can hide that. Similarly, solar panels, they do not generate base load at night. They will not work for what we need, so we can hide that. Geothermal, in some areas, geothermal is possible. In tectonically active areas like Iceland and California, geothermal might do the trick, but it will not work in northern BC. And so now we have shrunk our options down to a manageable 4 options. And that makes our job much easier because it's a much more straightforward task to compare 4 options to each other compared to comparing 8 options to each other. And so now that we've got our primary criteria out of the way, we can put check marks or Ys in all of these just to be transparent and to show everybody why these survive the primary criteria screening. So we now have 4 options, all of which can meet our objectives. It doesn't mean any of these are the best or any of these are preferable or that any of these are great options, but it means they're all worthy of comparing to each other. So now let's look at secondary criteria. So I mentioned earlier, we're using the triple bottom line known as social, economic, and environmental considerations. And what we need to do is we need to weight them. So in other words, how valuable are all of these things compared to each other? The weighting is going to be some score out of 100. And I've got some math that you can see if I double click in here. So this is just going to be the sum. And inside these cells, what I've got is multiplying the weight times the rank to get the score. So in other words, if something is ranked very highly, it will lead to a higher score. So to start with, let's say that environmental, economic, and social must all be equal to 1/3 of 100. So 33, 33, and one of them must be 34. And since we are environmental scientists, let's say environmental must be worth 34. So that means these 4 categories must add up to 34. And so now within that, we can say maybe minimizing disturbance and minimizing carbon emissions are worth a little bit more than the others. Let's call those worth 10. And let's call those worth 10. And if we say minimizing terrestrial disturbance and minimizing air pollutants are sort of equal to each other, this will add up to 34. And then if we go down into economic, we have an initial outlay of dollars, which is known as CapEx or capital expenditures. And we have an OpEx or annual cost. So this is our initial principal that we must spend, and this is how much it's going to cost us forever. And let's say we care more about future taxpayers or ratepayers than present because they must pay forever. So we'll make annual cost worth 17, initial cost worth 16. And then we have social impacts. This is going to be worth 33, but are they all equal? So minimize displacement of communities, minimize effects to human health, and use of renewable resources. I would argue that human health is almost always going to trump everything else. If we are proposing a project, and I'll just foreshadow a little bit here, like coal-fired power plants, which can cause cancer and lung disease and all sorts of other ill effects. Even though having people displaced is unfortunate, nobody likes it when a farmer gets their land expropriated. It is certainly better than having people die of cancer. So I'm going to say that this category is worth about 15. Maybe displacing people is worth 10, and using renewable resources is 8. And if I did that math correctly, we can see down here that this adds up to 100. So we now have weightings. We have weightings that are approximately equal. So about 1/3 for environmental, about 1/3 for economic, about 1/3 for social. And within these categories, we have weightings that show some preferences as to how we value each of the criteria. And now what we're going to do is we're going to rank each of the options, and we're going to do it in such a way that we do it one line at a time, completely ignoring everything else. So one way to do that is to hide all the rows. Another way to do it is just to focus exclusively on these 4 ranks, looking purely at the description and the criteria, and you'll see it's a little bit easier to actually just do it than to explain it. So if we look at minimizing aquatic disturbance, we have stream removal or pollution. Well, let's just talk about these before we rank them. So a hydroelectric dam is going to definitely have an aquatic disturbance. It's going to flood some tributaries. It's going to change river into lake habitat. But certainly there will be an aquatic disturbance. A gas-fired power plant, in all likelihood, a gas-fired power plant and a coal-fired power plant will have some sort of a blowdown, usually some sort of a cooling pond, and it might have some pollution to a river. Probably coal would be more pollution than the gas-fired, and maybe the biomass-fired would be a little bit cleaner. But I think it's fair to say that the hydroelectric dam would have by far the largest um, aquatic disturbance, so that gets a 1, because remember the highest score is the best. And if we say that the biomass fire would have 4, gas-fired would have a 3, and a coal-fired would have a 2. Now, maybe these scores are incorrect. Maybe if there was another expert in the room with me right now, that expert would correct me and say gas-fired is higher than coal-fired or vice versa. But that's the benefit of having a large group and doing these. Unfortunately, I'm by myself, so I'm just kind of guessing at some of these. But the whole point here is to go through the process and see what happens as opposed to make the perfect scores. So minimizing terrestrial disturbance. So again, hydroelectric dam is going to be probably the biggest disturbance. It's going to turn many square kilometers of terrestrial habitat into aquatic habitat. And if you happen to like aquatic habitat, that might be a good thing, but generally any disturbance to habitat, whether it's aquatic or terrestrial, is negative. And remember, we're looking at one criteria at a time. We're not going to say, well, I actually like aquatic habitat, so that disturbance isn't all that bad. We're just going to say, what is the disturbance to terrestrial habitat, regardless of what the offsets might be. Okay, so gas-fired, coal-fired, and biomass-fired, these all have terrestrial disturbance. And now having said that about the hydroelectric dam, I'm actually going to change my mind. A coal-fired plant has generally a coal mine to go with it, and that is going to have an extraordinarily large terrestrial disturbance. So that makes hydroelectric number 2, and then we have gas and biomass, and let's say the gas-fired plant leads to cut lines and other infrastructure on the land. It's going to have some disturbance, still better than a coal mine, and then a biomass, let's say, is working entirely off of uh, agricultural waste and it's got hardly any disturbance on its own. Okay, minimize air pollutants. Here's where hydroelectric is going to shine. It will have very low emissions compared to any of these. It will have some emissions as they're building the dam. They'll be using concrete, which has a lot of emissions, but once the dam is operating for the next century, it will be much cleaner than any of these options. And I'm going to go out on a limb here and say that gas-fired would be the second cleanest because natural gas burns very cleanly. It basically creates the fewest pollutants. Biomass would be 2 and coal would be 1. And then carbon emissions. Again, hydroelectric is going to be the clear winner here. Biomass, let's say this would be the second best because anything that gets burnt would have rotted anyway and would have created CO2. Coal-fired, again, would be the worst, and gas-fired would be number 2. So as you can see, I'm using only integers. This is what I referred to earlier as only using integers in my rank, and I'm not allowing any ties. We must have everything ranked from 1 to 4. Okay, so CapEx and OpEx. These are all pretty expensive. There's nothing cheap here. Coal is actually generally the cheapest. I did look up some cost-benefit analyses before doing this. It's actually quite cheap to run coal compared to any other option. Hydroelectric, depending on where you are, will vary, but is often number 2 in this ranking. Gas-fired would be the third best, and biomass in terms of cost is actually not very cheap, even though the feedstock is often quite cheap. The feedstock is usually not where you need it to be, so you have a lot of transportation costs and it's not very efficient to burn. And the technology just hasn't evolved as much as the other 3. Okay, so then the annual cost. Once the dam is built, you actually have a pretty good annual cost because you're not continually feeding something to generate electricity. Coal is the second cheapest, followed by gas-fired, followed by biomass. And again, this will vary depending on where you are. There's lots of assumptions that go into this. The purpose of this, though, is just to show some rankings, not to kind of actually do a full cost-benefit analysis. Okay, so social. Minimizes displacement of communities. Hydroelectric dam here is going to be the worst because it floods out people's properties. A lot of land is expropriated, whereas with the other plants, they have a smaller footprint. Even though coal-fired does require a dam, or sorry, a mine, usually those mines are not where people live. The mines are way out in the middle of nowhere, and there's really actually no shortage of mineable areas whereas with a hydroelectric reservoir, there are very few areas left where you can actually put in a new reservoir. So there's very few options there. Gas-fired has very little or no displacement because it's very flexible in terms of where you can put it. And then biomass is similar. There's no need to displace anybody. There's no need to expropriate land. You essentially can build those things wherever you've got the feedstock nearby. Next, minimize effects to human health. Now this one would be hotly debatable, but for sure we can say that coal-fired power plants would be lowest on the list. Most likely we can say that gas-fired is second lowest. And then because biomass does have air emissions, it's probably second lowest with hydroelectric at the top. Using renewable resources, this one again could be open to debate. Biomass is probably the best, followed by hydroelectric. Depending on where you're getting your biomass. If it's entirely a waste product, you can actually divert streams from going to landfills or other areas and reduce the total amount of waste produced from the status quo. Gas and coal, neither of these are renewable, but because coal is in a much higher supply than gas, even though nobody likes coal, it's got a lot of adverse impacts. There is an extraordinarily huge amount of coal. There's about 2 centuries of coal left. And so gas would be slightly lower. Now what you can see, you may have been following along, maybe not, but what you can see now is that each of these options has a total score, which is just the sum of each individual column. And what we can see is that hydroelectric, in this case, is the highest score. So the other three options are actually pretty close. We can see that coal is the lowest. Biomass and gas are essentially tied. They're within about 2% of each other in terms of total score, maybe 3% of each other. And with the accuracy at which we're working here, that's not really a significant difference. But what we can see is hydroelectric is the clear winner. Now, a couple of other things about this. Normally what we would do is we would add a little comment. And so anything that's a real differentiator here, we would want to go back and add a comment to explain to people why we chose the score we chose. So for example, annual cost, no feedstock. And for coal, we would say cheap feedstock. For biomass, we would say expensive to ship. Even though the feedstock might not be expensive, it's the shipping. And all this does is it explains to somebody if they want to come back and look at this in a week or a month or a year, and they can understand. And so for gas, we would say current prices are expensive. So currently gas is expensive. And we would do the same thing with all of these columns, with all of these cells. We would fill in some kind of a comment to explain to people why we chose what we chose. Now, where this gets interesting is if we want to do a sensitivity analysis. So we've got our base alternatives, and I'll just save this file. But what we can do is we can make a copy of this, And so I'll create a copy, and I now have an identical sheet. And what I can do is I can come back here and I can say, what if our values were to change? What if we now care so much about CO2 emissions because Canada just signed a new treaty that CO2 emissions are now twice as important as anything else in that category? So what would that mean? That would mean CO2 is worth about 15, and by extension, minimizing aquatic disturbance would have to drop down to about 6, and one of these would have to drop down also to about 6. And so now, again, this has to add up to 100 in this particular example. But now CO2 is worth about twice as much as everything else. And by doing this, we're doing a sensitivity. We're saying, does the answer change? Is it sensitive to those CO2 rates? And as it turns out, the answer is not sensitive because hydroelectric is still the winner, coal is still the loser, and gas-fired and biomass-fired are still pretty much tied. And so now I can undo that and I can set it back to the weightings I had earlier. But I could say, well, what if we know that all of these projects have really good emissions controls, and we know that human health is not going to be risked for any of these, and in any circumstance, the company has committed to doing a risk assessment and mitigating any sort of effect to human health. And that means what we can do is we can essentially just take this right off the table. So what I'll do is I'll just kind of gray it out. I'll set this to 0. And again, this is just a sensitivity analysis. So what that means is now displacement and renewable resources take up this whole category. So let's say this is worth 17 and this is worth 16. Again, my scores add up to 100. Is our decision or our options analysis, is it sensitive to that change? And again, we see no. Hydroelectric dam is still the winner. Now we have these 3 options virtually tied, but it doesn't make any difference. Hydroelectric is still going to be the winner in this case. So let's do another sensitivity analysis. Let's look at what is driving the decision for hydroelectric to be the clear winner. In other words, where is hydroelectric getting its high scores from? So annual cost is a big driver. And we know that because the score here is 68. Human health is a big driver, but we've already checked that and it doesn't make a big difference. And so let's say, what if we only care about present cost and all of the future cost is just for this moment going to be ignored? So we put all of the weight on present cost. Now what happens? Well, hydroelectric is still the winner. And so whether or not you like hydroelectric, it's not really the point here. The point is that we can do this sensitivity analysis. We can go through and we can check, even if we're totally wrong about one value that we've put in. What if we're wrong about 2 of them? We can keep playing with this just to see, does this overall ranking change? And if the number doesn't change, we can be very confident that we've got the best option. And we can also then defend our decision. And so this works not just with large scale projects like this, but any sort of decision that we need to make where we have multiple people wanting different criteria to be weighted or valued. Even in our own lives, for example, I actually did this last time I bought a house. When I moved from Calgary to Kelowna, I really couldn't decide on what I wanted in a house, and I knew it was going to be a house that I live in for many years and might even be the last house I ever buy. So I built a tool just like this and ranked all of the different criteria, like the number of minutes it would take to commute to work, the cost of the house, the square footage of the house, the square footage of the land. I even put in there some criteria around whether or not my yard contained 1 or more ponderosa pine, because I love ponderosa pine. But you can put anything you want in here. And it's not so much the value of getting this high score at the end, but what it does is it makes you think through comparing all these options to each other based on one criterion at a time, and it makes you really understand your decision. And so it makes you understand your decision, but it also helps you defend your decision if you need to. It makes it transparent to stakeholders, and it really just helps you with that overall thought process. So I hope you find that useful. I'm going to post this file that you're seeing now on Canvas in case you'd ever like to do one of these or play around with it, or just kind of look at the formulas that I've used here. So that is it for options analysis. I really enjoy doing this. I hope you get a chance to in your career. It's a lot of fun and it really helps you think more clearly about things. So have a great week and we'll see you next time.